This is 3.05 Buffers and Titrations Part 2. Sorry, I'll really try and watch the timer a little bit better because my time ran out on the last video. So if you didn't get a chance to pause it and look through the rest, we are finding the concentration of HCl, and so it has to be moles per liter. So we have to change to milliliters again into liters, and then take your 0.00016 moles HCl divided by 80 milliliters, which gives you 0.002 HCl. By using titration, you have found that the concentration of the unknown solution is 0.002 moles per liter or molar of HCl. Here are a few last words about titration. So far you have learned only about titrating to find an unknown acid concentration. You can use titration the same way to find an unknown base concentration. The only difference is that the solution starts out with a basic pH and gets more acidic. The pH at the equivalence point is around 7 for both titrations. Once the equivalence point has been passed, an indicator, one that changes color in acid, will change color. So this time we started with a base, so a nice high pH, and then it's slow, slow, and then boom, hits the equivalence point, and then boom, goes down, and it is acidic. Into my notes, I added the previous problem, and then I also added you can use titration the same way to find an unknown base concentration. If you use phenolphthalein, because remember you do need an indicator as well, now it will start pink because you're starting as a base, and it will turn clear after it is neutralized. It is possible to stabilize the pH of a solution and to determine the concentration of an acid or alkaline solution. Buffers help to maintain the pH of a solution at a constant level. Remember, not neutral, constant. Buffers are mixtures that can absorb or release hydrogen ions to keep the pH constant. Titration is a carefully controlled neutralization reaction in which a solution of a known concentration is added to another whose concentration is not known. This drop-by-drop procedure helps pinpoint the exact concentration of the unknown solution. An indicator that changes color at certain pH helps in the monitoring of the progress of a titration. pH is stabilized or kept constant by buffers. pH is determined by titration when it is unknown, which uses indicators and is based on neutralization reactions. And that's it for this section.